Welcome to the first warm-up of our new unit. Looks a lot like our old unit, though, which kind of makes sense because if it's the first day of our new unit, we haven't learned it yet. So the warm-up is still going to have to be the old unit. So sorry if that's a little anticlimactic. All right. So basically you had a big matching game here. And you were trying to figure out which statistics went with which histograms. So it's good to have a strategy here. The way I approached it was I started by focusing on these three right here. All right. And I focused on those three because those are the three where the mean and the median were different. All right. And what we learned is that when the mean is greater than the median, all right, that tells us that the distribution is right skewed. And when the mean is less than the median, like it is over here, all right, that tells us that it's left skewed because those observations at the end of the tail are dragging down the mean. All right, so this one there's only one left skewed distribution in this whole table. So if we go up to our pictures, we can see that this is our only left skewed distribution. So that number 5 here has to be histogram C. And the reason is it's the only one that's left skewed. All right. So that brings us to the two right skewed. Now, if we look at our pictures here, these are our two right skewed graphs. All right. This one's right skewed. This one's right skewed. It's got its tail going off to the right. It's got its tail going off to the right. This one's up and down, but it's pretty symmetric. This one's even more symmetric. This one's bimodal, but it's sort of like the two bimodals at either side sort of kind of balance each other out. So when we're looking at, the skew, we've got a right skew here, we've got a right skew here. Now, if we look down at the numbers, the only difference between these two is that one has a standard deviation of 10 and one has a standard deviation of 20. All right. Now, you have to remember standard deviation is the average distance from the mean. All right. So it's how spread out things are. So if the mean is 53, we're looking at, which one has more values that are a large distance from 53. Now, you might be saying to yourself, well, it looks like this one goes out much further, but you have to pay attention to the scale. All right. So this one, the smallest observation is below 20. All right. And if we're assuming each of these is about, 5 or so, or a little more than 5. So this is below 20, and it goes all the way up to above 100, basically to like almost 110. Down here, the lowest observation is actually somewhere between like 40 and 35, and the highest observation is somewhere over 75. So if you just visually look at these, it might look like this has things that are further away from the mean, because you might be saying, oh, the mean's probably right around here, and look at these way out here. But when we look at the scale, we can actually see that this one has way more observations that are a good distance from the mean. So this one's going to have the larger standard deviation, and this one's going to have the smaller standard deviation. All right. And the reason is, there's two reasons that we were able to identify it. One is that it's right skewed, and the observations are less spread out. And then this one is right skewed, and the observations are more spread out. And the key to this one was looking at the scale. All right. So you had to look at the scale, because just visually looking at it could make you think that one was higher than the other. But when you actually looked at the numbers down below here, it makes it a little clearer. All right. So that brings us to the final three. All right. And if we look at these final three, they all have the same mean. They all have the same median. The only thing that's different is their standard deviation. So we're basically just trying to rank these final three, A, D, and F, from lowest standard deviation to highest standard deviation. All right. So remember that in each case, the mean is 50. So here's our mean line. Here's our mean line. And here's our mean line. Now, again, it can be helpful to look at the scale. All right. The lowest value here is 40. The highest value is somewhere between 60 and 65. All right. So it's got a range roughly of about 20. All right. Not exact, but roughly about 20. If we look at this one goes to just shy of 70. And the lowest observations are around 30. So this one's got a range of about 40. And then if we look at this one goes from about 20 to about 70. So this one has a range of about 50. All right. So this one has the biggest range. This one has the smallest range. This one's in the middle. And not only does this one have the biggest range, but you'll notice that it has the most observations the furthest distance from the mean. And remember, standard deviation is the average distance from the mean. So not only are these bars further away from the mean, but there's a high number of observations that are far away from the mean. So by far, this one's going to have the largest standard deviation. All right, so this would be histogram D. And the reason is lots of observations that are far from the mean. So it has lots of observations that are far from the mean. Then now we're down to just these two. All right. And we can see this one has a range of 20. And not only does it have a range of 20, but as you get further from the mean, the count of your observations gets pretty low. Like there's not, first of all, they're not even that far from the mean to begin with. And when they are far from the mean, there's not that many. There's like one or two here. So that's the one that's going to have our lowest standard deviation. So most of the observations are close to the mean. Sorry if you wanted to know who is being called to the greeter desk, but I decided to pause the video. All right, most of the observations are close to the mean, which then leaves this up here as our histogram A. Now, I guess the reason could just be process of elimination, but we can just say something like, some observations are far from the mean, but a lot are also close. It's kind of that too hot, too cold, or just right. We've got our little Goldilocks graph here for histogram A. All right. So again, thinking about standard deviation, thinking about the definition of standard deviation being able to draw connections between the visual and the numerical. This is kind of just like a nice wrap up of what we did in that first unit. All right, so hope this was helpful. I hope you did well on your guesses, because they weren't guesses, they were analytically driven choices. And if you have any questions, let me know.